All right, we're going to be looking at 1.6, deductive reasoning. Okay, so deductive reasoning is the process of reasoning using given and previously known facts. And we're going to use those facts to reach a logical conclusion. All right, so our first example, given that a conditional and its conclusion are true, can you use deductive reasoning to determine whether the hypothesis is true? Okay, so for this, we're going to set up a truth table. Try to... Okay, so if our hypothesis is true and our conclusion is true, we know that our conditional is true. If our hypothesis is true, but our conclusion is true, we know that the conditional is, if the hypothesis is true and the conclusion is false, we know that the conditional is false. If the hypothesis is false, but the conclusion is true, then the conditional is true. And then last, if our hypothesis is false and our conclusion is false, then the conditional is true. Okay, so this is our truth table. They are telling us that the conditional and the conclusion are true. We want to figure out if our hypothesis is true. So I want to look at all of the scenarios where my conditional and my conclusion are both true. So my conditional and conclusion are both true in that situation and in this situation. Okay. So we need to figure out if our hypothesis is true if both of those pieces are true. Well, we have here that the hypothesis is false, so we cannot prove that the hypothesis is true. So then our try it, given a conditional and its hypothesis are true, can you determine whether the conclusion is true? Okay, so the only one where our conditional and the hypothesis are true is this first one. So because that is the only conditional and hypothesis that are true, then this is true, that we can determine that the conclusion is true. So yes. Yes. Okay. Law of detachment. All right, so the law of detachment is a law of logic that states if a conditional statement and its hypothesis are true, then its conclusion is also true. Okay, so if P then Q and P are true, so if the conditional and the hypothesis are true, then the conclusion has to be true. Okay, so let's look at our first example. Okay, so for example 2, we need to assume that the set of given information is true. If Alicia scores 85 or higher on her test, she will earn an A as her final grade. Alicia scores 89 on her test. What can you logically conclude? So our conditional is that if Alicia scores an 85 or greater on her test, then she will earn an A as her final grade. Okay, so then our hypothesis is that if Alicia scores an 85 or greater on her test, okay, well then they tell us that she got an 89 on the test. Well, 89 is greater than 85, so we can conclude that Alicia will earn an A as her final grade. Okay, so then our next one, that's on the next page. Okay, we'll do our try it first. If two angles are congruent, then the measures of the two angles are equal to each other. Angle 1 is congruent to angle 2. What can we logically conclude about the measures of angle 1 and angle 2? Okay, so PQ, P then Q. So if two angles are congruent, right? So if two angles are congruent, then the measures of the two angles are equal. Okay. Our hypothesis is that if two angles are congruent, okay, so we can conclude that the measure of angle 1 is equal to the measure of angle 2. All right, so our B example. If point D is in the interior of angle ABC, then the measure of angle ABC equals the measure of angle ABD plus the measure of angle BDBC. Okay, so we're using angle addition postulate. What can we logically conclude about the measure of angle ABC? Okay, so our conditional is telling us that if point D is in the interior of angle ABC, then the measure of angle ABC will equal the measure of angle ABD plus the measure of angle DBC. Our hypothesis is that if point D is in the interior of ABC, okay, so we can conclude that the measure of angle ABC would equal the measure of angle ABD plus the measure of angle DBC. So our try it, if you finish the race in under 30 minutes, you will win a prize. You finished the race in 26 minutes. What can you logically conclude? Okay, so since 30 is greater than 26, we can conclude that you won a prize. Okay. All right, next we're going to look at the law of syllogism. All right, so it is a law of logic that states that given two true conditionals with the conclusion of the first being the hypothesis of the second, there exists a third true conditional having the hypothesis of the second. So we would see that as if the first conditional and the second conditional are true, then there is a third conditional that is also true. Okay, so let's look at our first example. All right, if Kenji plays the trumpet, then he plays a brass instrument. If he plays a brass instrument, he is a member of the marching band. Okay, so we need to get this all set up. So our P, Q, so if P then Q, if Kenji plays the trumpet, then he plays a brass instrument. Then our second conditional is that if he plays a brass instrument, then he is a member of the marching band. Okay, so if both of those conditionals are true, then we can conclude that if he plays the trumpet, then he is a member of the marching band. Let's look at B. Nope, it's on the next page. Okay, we'll look at that in a second. All right, let's work on this. Try it. Assume that each set of conditionals is true. If an integer is divisible by 6, it is divisible by 2. If an integer is divisible by 2, then it is an even number. Okay, so because the conclusion to my first conditional is the same as my hypothesis for the second conditional, then I can put them together. Okay, so then PR is going to be that if an integer is divisible by 6, then it is an even number. So next we've got our example. So if point A, B, and C are collinear and D and B is between A and C, then ray BA and ray BC are opposite rays. If ray BA and ray BC are opposite rays, then BA plus BC equals AC. What can we conclude? Okay, so we've got a lot going on here. Let's break it down into statements. So our first statement is if points A, B, C are collinear, and B is between A and C, then ray BA and ray BC are opposite rays. Okay, our second conditional is that if ray BA and ray BC our opposite rays. Then BA plus BC equals AC. Okay, so then our conditional that we can conclude would be that if points A, B, C are collinear, and B is between A and C, then we can conclude that BA plus BC equals AC. Okay, so what I'm doing is I'm putting together the hypothesis. Oh, let me change. I'm putting together the hypothesis from my first conditional with the conclusion from my second conditional. Okay, let's look at the try it. All right, if it is a holiday, then you don't have to go to school. If it is Labor Day, then it is a holiday. Okay, so on this one, they actually have the statements flipped. So this second one is actually the first conditional statement. Change the color. So this would actually be the first conditional statement, and this would be the second conditional statement. So the conclusion from my first conditional statement matches with the hypothesis from the second conditional statement. So to write my concluded conditional statement, I would have that if it is Labor Day, then you don't have to go to school. Next. All right, now we're going to apply these to draw conclusions. Okay. If you are climbing a mountain at an altitude of 28,500 feet or higher, then you are on the tallest mountain above sea level on Earth. If you are on the tallest mountain above sea level on Earth, then you are on Mount Everest. You are climbing a mountain at an altitude of 29,000 feet. Okay, so let's first look at the law of detachment. So they told us that we were at 29,000 feet, which is greater than 28,500. So we can conclude, using the law of detachment, that we are on the tallest mountain above sea level. Law of syllogism. Okay, so if we are climbing a mountain at an altitude of 28,500, then we are on Mount Everest. Martin walks his dog before dinner every day. Martin is now eating his dinner. We're going to use the law of detachment. What conclusion can we draw from these true statements? Okay. So P, Q. Okay, so we can conclude that if Martin is eating dinner, then he has already walked his dog.